morning, students. We have introduced the basic concept of surface tension. We know that free surface of liquid at rest tend to contract. Why? In order to acquire minimum surface area due to surface tension. So if area of the free surface of the liquid has to increase, so some work has to be done against the force of surface tension. This work done will appear as potential energy. That means this potential energy of increased area is called surface energy. So how can we define it? That surface energy of a given liquid surface is defined as amount of work done against the force of surface tension in forming the liquid surface of given area at constant temperature. So this way you can define. It means it is simply formed. We can define that it is the amount of work done against the force of surface tension in forming a liquid surface area. To obtain the expression for surface energy, let we take a rectangular frame. See, this is a rectangular frame I have taken, having wire PQ. We are taking this wire PQ, which can slide along this length. So this frame which I am taken, that is A, B, C, D, and PQ wire, this can slide along the side A, B and C, D. Now here let me take a soft layer, and this frame is dipped into the soft film. What will happen then? Here will be two surfaces of soft film, where air and soft film will be in contact. So as we are dipping this soft, you can see this rectangular frame within the soft solution, two layers will be formed where air and soap are in contact. Now the force of surface tension act tangentially inward. If we are representing the surface tension, this is acting tangentially inward and perpendicular to the sides on both the free surfaces of the liquid. It is acting like this. Now all these sides are fixed. Now if we want to increase the area of this soft film, what should we do? As this is a slider which is free to move, so very gently this can be displaced outward. So PQ can be shifted to any other position. Let it be P dash, Q dash. Let it is displaced through a small distance x. This is to be done very gently as we are extending it, as we are moving it outward. So correspondingly here this soap film area will be increased. Now let S is the surface tension of soap solution which we have taken, and L is the length of wire. Which wire? PQ. This, see, you can see this wire PQ, its length is L. As we have already explained that there are two films where soap and air are in contact. So one on this side and another on its back side. यानी फ्रेम के दोनों तरफ ही सोप फिल्म बनती है where air and soap are in contact. So it means now total force which is acting inward, that will be given by S into 2L. Why 2L? Because force is acting on both the surfaces. Now to increase the area of the soap film, we have to pull PQ through a distance x. So the increase in area of soap film, that will be, let me represent it by del A, and it will be equal to, अब देखिए यहाँ पर, see in the figure, this is the length and this is the breadth. Length is L, breadth is x. Now when we are extended it with the force F, so increase in area कितना हो जाएगा, यानी ये complete area का increase हो जाएगा. It will be 2 into L into X. So it is 2 into L into X. This is the increase in area of soap film when the force is applied outward. So now work done in stretching the film. This will be given by force into displacement produced. As force is S into 2L, so it is S into 2L into X. Now this 2L into X, this can be treated as the increase in both the films. So here it will be S into del A. Now here you can see here that work done in stretching the film is S into del A. So here this work done is appearing as the surface energy. So from here if you want to calculate surface tension, it is E upon del A. Right? So surface tension of a liquid is numerically equal to surface energy per unit area of the liquid surface. From here you can just see. And if increase in area is unit, then only you can say surface tension is equal to surface energy. Right? So this way it can also be proved that surface tension is numerically equal to surface tension. Then directly you can prove it. So this way you have explained, you have derived the expression for surface energy in terms of surface tension. You have to learn this formula that it will be used directly in many numericals. Now next we have to discuss excess of pressure on curved surface of liquid. As we know that liquid molecule on the surface of liquid is attracted by force of cohesion in all the directions. As we take that liquid is here, so molecules, force of cohesion, molecule, force between the molecules of same substance. तो इसमें force of cohesion सभी directions पे लगा हुआ है. So liquid molecule on the surface of liquid is attracted by force of cohesion in all the direction. And force of surface tension also act tangential to the liquid surface at rest. Now the direction of resultant force on the molecule basically depend upon the shape of liquid meniscus. So what can be the shape of liquid meniscus? It can be plane, it can be concave upward, it can be convex upward. So we can treat it that the liquid meniscus can be plane or it can be curved. Now if liquid surface is plane, we have to just learn the result on this basis. If the liquid surface is plane like this, just this top view, it is the plane. Then let me take a molecule O. This is the molecule on the liquid surface. It will be attracted on all the sides equally. So the force of surface tension, let these be SS, these will be acting tangential to the liquid surface in opposite direction. क्योंकि meniscus plane है तो सर tangent कहाँ होगा? This is along the line, along the surface of liquid, and this molecule will be equally attracted in all the directions. So hence, what will be the result? Now no resultant force is acting on the molecule at O. Why? Because these forces of surface tension, these are balancing each other. Hence, resultant force acting normally on the liquid molecule is 0. It means no extra pressure is communicated to the inner side or on the outside surface of liquid. So you can say that pressure on the liquid side is equal to pressure on the vapor side. देखिए pressure on liquid side यानी अंदर liquid के अंदर की बात कर रहे हैं. So the pressure यहाँ है, that will be same as pressure on the vapor side when the liquid meniscus is plane. So you can just take the conclusion from this. If the liquid meniscus is plane, liquid surface is plane, so pressure on liquid surface is equal to pressure on the vapor side. Only when the liquid surface is plane. Now if the liquid surface is curved, curved can be concave upward or convex upward. Like we can take, like the meniscus is like this, or it can be like this. Like the molecule is taken, here we are taken the molecule, the liquid is taken in this manner. So like we have taken the molecule here, only one molecule we have taken. This molecule on the liquid surface is acted by force of surface tension. This is along tangent, as this is a curve, so tangent will be along this direction. Now resolve these tension. What we will find here, when you will resolve, this will be, if this angle is theta, this will angle is also theta. So this component will be s cos theta. This will be again s cos theta. So vertical component इसकी वजह से और इसकी वजह से क्या होगा, s sin theta, s sin theta. यहाँ पे भी देखेंगे, यहाँ पर भी देखिए ये फोर्स ऑफ सरफेस टेंशन एक्टिंग टेंजेंशियली. अब हॉरिजॉन्टल के साथ इक्वल एंगल पर है, तो ये कंपोनेंट दोनों ही इक्वल कैंसिल कर जाएंगे, एस कॉस थीटा, और वर्टिकल कंपोनेंट दिस विल बी एस साइन थीटा. So if the liquid surface is curved, on resolving these components, the surface tension, horizontal components are cancelled out, but vertical components are added. Thus, resultant force would be acting on the curved surface of the liquid, which act towards the center of curvature. It means resultant force is directed inward in case of convex surface, and in case of is directed outward in case of concave surface. So what should be the result? Now for the curved surface of liquid in equilibrium, प्रेशर ऑन, अब यहाँ पर इसको बैलेंस के लिए, क्योंकि रिजल्टेंट फोर्स इस साइड है, तो इसको बैलेंस करने के लिए यहाँ से कुछ एक्सेस ऑफ प्रेशर होना चाहिए ऑन द कॉन्केव साइड, ऑलवेज ऑन द कॉन्केव साइड. सो एक्सेस ऑफ प्रेशर मस्ट बी ऑन द कॉन्केव साइड. सो व्हाट वी कैन राइट, फॉर लिक्विड surface to be in equilibrium, pressure on concave side of liquid will be greater than pressure on convex side. You can see here, as there is some resultant force acting on the curved side or towards the center of curvature, so उसको counterbalance करने के लिए there must be some excess of pressure on the concave side. This is concave side and this is also on the concave side. So you must remember these two results. These will be very useful in doing next derivation part as well as conceptuals. Next derivation we are doing axis of pressure inside a liquid drop. This is important derivation. See, let we consider a liquid drop of radius r. The molecule lying on the surface of liquid drop due to surface tension, this will experience a resultant force inward perpendicular to the surface, as the size of this liquid drop cannot be reduced to 0. So what will happen, the pressure inside the drop, that must be, you can take this pressure inside the drop must be pressure outside. Therefore that's why you can say, due to this pressure this drop will not collapse to 0 size. So this excess pressure inside the drop will provide force acting outward. अब उस excess pressure के कारण क्या होगा, slight dimension में change आएगा, and this excess pressure will provide force acting perpendicular to the surface. Now here, as we have to obtain this excess of pressure, what will be the expression for this excess pressure? Let me take S is the surface tension of liquid drop, and you can say that P is the excess pressure inside the drop. Now what will happen, due to this excess pressure inside the drop there will be small increase in the radius. Let it be del r. Delta r भी लगा सकते हैं, del r भी लगा सकते हैं, one and the same thing. So due to this excess pressure on the drop, there is slight increase in the radius. So now work done by excess pressure. This work done will be given by force into displacement. And this force, we can express it in terms of pressure. So this is excess pressure multiplied by area into that displacement is increase in radius. See, this raindrop is, this is liquid drop, not raindrop. It's liquid drop. It is spherical in shape. So what will be its area? This will be 4 pi r square because r is the radius. This is the work done by excess pressure. Let it be equation 1. Now, as its radius is increased, there is increase in the area of this drop. So, increase in surface area of this liquid drop. This will be equal to final area minus initial area. So, 4 pi r plus del r square minus 4 pi r square. So, 4 pi, हम यहाँ पर a plus b square एक्सपैंड कीजिए, r square plus del r square plus 2r del r. इसमें से भी अगर हम 4 pi यहाँ कॉमन ले लें तो क्या रह गया? minus r square. This factor will cancel out. So now here you can see that del r is a small increase in radius. तो अगर del r की वैल्यू 0.1 है तो इसका स्क्वायर क्या हो गया? 0.01. यानी स्मॉल, वेरी स्मॉल, मे बी की ये वैल्यू बहुत ही कम हो, 0.01 हो, यानी जितनी स्मॉल वैल्यू है उसका स्क्वायर उतना ही स्मॉल हो जाता है. तो इस केस में हम क्या करेंगे? डेल आर बीइंग वेरी स्मॉल, सो इट्स स्क्वायर फैक्टर विल बी इग्नोर्ड. सो वी विल राइट दिस इंक्रीज इन एरिया एज 4 पाई मल्टीप्लाइड बाय 8 पाई आर डेल आर. ब्रैकेट में आप लिख सकते हैं बिकॉज डेल आर स्क्वायर इज वेरी स्मॉल, so we are ignoring it. Now, as this is the increase in area, so what will be the increase in potential energy of this drop? How will we express it? We will express it in terms of surface tension multiplied by increase in area. This increase in area is del A. So it is this is S into 8 pi r del r. Let it be equation 2. See, this is the increase in potential energy due to increase in area, and this is the work done by excess pressure. As both are representing the work done, both are representing the energy. So let me equate these two equations. On equating, P 4 pi r square del r, this is equal to S 8 pi r del r. Cancelling the common factor, del r will be cancelled, pi will also cancel, r will also cancel. Here it will be 2. So what is left? P into r equal to 2 into s. So pressure is 2s by r. This is excess pressure inside the liquid drop. So just remember the steps. What are the key steps here? First of all, you have to calculate work done by excess pressure. Due to that pressure, there is some increase in area, second step, and this increase in area will lead to increase in potential energy. So comparing equation 1 and 2, and you are getting excess pressure inside the liquid drop. As we have done excess of pressure inside liquid drop, now next important derivation we are doing, excess of pressure inside a soap bubble. See, the steps will be same as we have done in the previous derivation. Now, consider a soap bubble of radius r. Again, molecule lying on the surface of the liquid bubble will experience resultant force acting inward perpendicular to the surface. Why? Due to surface tension. Since size of the drop cannot be reduced to 0, it means that there exists pressure inside this liquid soap bubble. And due to this excess pressure inside the soap bubble, there will be slight increase in the radius of this bubble, as we have already explained in the previous case. So now few specification we need. Let S is the surface tension of soap solution. R is the radius, as we have already mentioned, radius of the soap bubble, and del R is the increase in radius of bubble, soap bubble, and P is the excess pressure inside the soap bubble. So now here, due to this excess pressure, some work will be done. This work will be done by force multiplied by distance. Force क्या होगा? Same steps as we have already done. Pressure into area multiplied by small increase in radius del R. So work done will be this one. Now this excess pressure will lead to increase in area of the bubble. अब main point जो हमें ध्यान में रखना है कि soap bubble has two free surfaces. This point is important और ये आपको लिखना भी है. Soap bubble has two free surfaces. One outside the bubble and other inside the bubble, where soap solution and air are in contact. So this is an important step. Now other step, there will be some increase in area. This increase in area will be 2 into final area. Final area कितना होगा? 4 pi r plus del r square minus initial surface area 4 pi r square. अब सॉल्व कीजिए यहाँ से, तो 4 pi जस्ट कॉमन रखिए इधर, और ये आ गया r square plus del r square plus 2r del r minus r square. 4 pi दोनों में से कॉमन लिया. Same step you can see here. This is your 16 pi r del r. Here you can say this del r square is very small, so we are ignoring it. So now due to this increase in surface area, now here will be increase in potential energy, that will be surface tension multiplied by increase in area. This is S into 16 pi r del r. From equation second and this from equation this first. So comparing these two equations, what we will get, P into 4 pi r square del r equal to S into 16 pi r del r. So del r is cancelled, this r, this pi and this 4. So pressure, this comes out to be 4S by R. It means pressure inside the soap bubble is 4 times that of S upon R. जबकि liquid drop में क्या आया था? In the liquid drop it was 2S by R. So this is the difference कि soap bubble में यहाँ पे 2 films होते हैं where air and soap are in contact. So remember this point, this is very important. Rest all steps are identical. If you have been asked find excess of pressure inside air bubble, तो air bubble के केस में आपके पास when it has been given for the case of air bubble, excess pressure वही होता है 2S by R. Excess pressure inside the air bubble. So you have to do the same case as that of the liquid drop. यही वाला केस आपको प्रूव करना है, इसमें कोई भी अलग स्टेप नहीं है. So you will do it by yourself. There can be the question, find an expression for excess pressure inside air bubble. So do it as the case of liquid drop. अब अगर हमें कंप्लीट टोटल प्रेशर बताना है, क्योंकि एयर बबल, मान लो हम ये कहते हैं कि लिक्विड के अंदर एयर बबल कहाँ बन रहा है, किसी हाइट पर बन रहा है, तो एक्सेस ऑफ प्रेशर व्हेन एयर बबल लाइक वी आर टेकिंग, दिस इज हैविंग रेडियस r and it is at a depth of h from the below the free surface of liquid. So excess pressure, अब क्या होगा, the excess pressure inside the bubble, क्योंकि इसमें हाइट का भी इफेक्ट होगा, तो टोटल प्रेशर कितना हो जाएगा, एक तो हो जाएगा इस एयर ड्रॉप के, एयर बबल के अंदर का प्रेशर प्लस प्रेशर ड्यू टू दिस हाइट ऑफ द लिक्विड h, where rho is the density and g. h is the height of liquid, rho is the density of liquid, g acceleration due to gravity. So this formula can be used directly in the numericals. See, whenever this air bubble is formed at certain depth, so that depth is also contributing to it. So now that's all for today. Revise all the concepts, practice these derivations. These are very important, and you have to learn the formulas also for numericals. Thank you. Have a nice day.